But without further ado, that's enough of me talking. I'm going to hand it over to the stars of the show. First up, team from MHacks. For those of you on the line, just so you know, our teams have 3 minutes to present, followed by about 3 minutes of questioning from our judges. We have a speaker clock here to time them. And then we're going to roll through a total about the top 6 teams. At 30 seconds, I'm going to call 30 seconds so you know you're near time. And at time, we will cut you off.
Thank you. Thanks so much for the introduction. We are Team MHacks, also known as Team CS at Mines. My name is Sumner.
I'm Jack.
And I'm Fisher.
And Sam is in the back waving at the camera. And we are super excited to be able to tell you about our hackathon project, HypAR Map.
The inspiration for our hackathon project actually came during our tour at Facebook here. As we were walking around, we saw these really cool maps on the ground that gave us orientation and location with the little red dot. And we thought, well, we're at a hackathon. We might as well digitize this map. How can we do this? So we built a really great indoor navigation system.
So Sam, go ahead and place a marker. So what Sam's doing is placing a marker on the wall. We took a picture earlier today of the fire exit map over by the emergency exit. And now what you can see is that he is marking the real world wall and lining it up to the wall in the virtual map that we imported into our application earlier today.
Yes, and we use AR Core in order to get all of our geometric data and calculations about where the wall is and how far it is from him. And we use the what AR Core calls anchors to save positions in the real world that we can then use later to calculate distances and to kind of visually look at as he moves around. And now he's going to head outside where we haven't placed any anchors. There are only anchors in this room. But because of how HypAR Maps works, it's able to figure out his location on the map using only the anchors, the 3 anchors he placed.
So the way that the anchors work is that once we have identified the wall and 3 of them, we calculate using the distances from those walls and the normals from those walls where the person is in relation to the walls, and then from because the user marked where the walls are in the virtual map here, we're able to triangulate their position on the map and have the red dot moving along with Sam as he's coming around. He'll be entering in on this side.
So while Sam's entering in, I wanted to talk a bit about the future. And so right now, our application works 100% offline. You don't need any cloud APIs at all. All the calculations are on device. But something great about AR Core is you can actually have cloud-based anchors. And
yeah, and and these anchors can be uploaded to the internet, and then other users of HypAR Maps can download those anchors, and instead of having to place them themselves, they can use ones that have been already created by a community of users, and just speed up the process of getting maps for places that they otherwise might not really be able to navigate.
And Sam has just arrived in the room. Come on up, Sam.
Come on up and introduce yourself, Sam. Take a bow.
Hi, I'm Sam. I did a lot of math.
All right, judges?
So you guys mentioned this uses AR Core. So what are the possibilities for having this cross-platform? Does this work on iOS, Android, Windows Phone? Is it limited? Do you have opportunities to expand beyond that?
Yes. We only have Android phones, but we know that ARKit exists on iOS. And we think that given that we've done a lot of the math ourselves, given that we've also done a lot of most of the calculations on our own. The translation to iOS should be fairly seamless, just having to change the few APIs for getting pin data.
And then we also, while we were kind of experimenting and look at the APIs, we noticed there is a very early development web version of AR Core. We didn't get it to work for us, but it's still in beta and very under development. So in the future, yeah, it could definitely be ported.
Google Maps has a ton of indoor data already. Were you able to map some of that onto your existing system, or is there some limitation?
The goal of this system was not to be reliant on external databases. Obviously, yeah, Google has a lot of buildings. There's a lot of buildings they don't have. The idea here is you could show up somewhere that you've never been before. In fact, that no one's ever been before. Just take a picture of like a brochure, any kind of map on the wall, any piece of paper, a phone screenshot, anything that is a representation of where you are. You can take a picture, immediately that VR view pops up, you hit a wall, align the wall, and then you just start walking. It will get, maybe it'll start to drift as you get further away, then hit another wall. Hit another wall. The more walls you have, the more opportunity the math has for error correction.
So could you elaborate a little bit more about when you take a picture and extract the map out of it? How does it work? Is it some functionality that AR Core provides for you?
So AR Core takes, so as you were seeing while I was walking around, the camera was seeing everything around me. AR Core uses that to produce a point cloud, and uses that point cloud to effectively give us some sort of a relative coordinate system. We have our own multivariate solver that takes that relative coordinate system, which we have no guarantees about, other than it's internally consistent, and use that to place the user into that map using their representation of where those walls they pinned exist.
As far as the importing the map into the application, currently it's just you take a photo with the camera. However, we know that there's plenty of things such as the scanner apps where you can align the corners properly so that it gets you a correctly oriented square map. And since that's a solved problem, we decided not to do that at this hackathon. Thank you so much. We really appreciate it.